Okay, let's go ahead and get started. Let me go ahead and switch over to the slide deck and let's hit the road. 2 o'clock sharp here in Denver time. So everyone over in Louisville time or elsewhere, thank you for joining. My name is Kevin TINN, and I'm going to do a presentation today on a couple infrastructure as code technologies that we really like here at Worldwide Technology, which is where I work. And so with that being said, let's go ahead and jump into my intro. So on that tangent, I am a cloud application architect and a practice lead at Worldwide Technology in our larger multi-cloud consulting group. Over a decade of industry experience, predominantly within software development. And so some work in .NET, mainly around C#. Once upon a time, VB, thank goodness those days are over. Within the JVM in Scala, and then also, you know, the kind of the standard JavaScript frameworks, etc. In the past, I'd say 3 to 4 years, really heavy shift into event-driven architectures, data streaming, etc. That's really getting hot right now. That's a conversation for another talk, though. And then obviously with the multi-cloud consulting aspect of my current role, a lot of work with the clouds, AWS, Azure, little GCP, and some on-prem solutions, but certainly stronger with AWS and Azure. A little bit about me, incessant traveler. Newfound it was a skiing addiction. Turns out it's sunny out here in Colorado these days, so picking up sailing. Live in Denver, as I mentioned. Was in St. Louis for quite some time, and then I was over in Tennessee where I grew up. So that's just a little bit about me. If you notice the AWS and Colorado logo in the bottom, that actually comes from a meetup that I organized, the AWS meetup group, and it's based in Denver. Prior to the coronavirus lockdowns, it was occurring all over the country. My partner Austin Lovelace and I were presenting in places like Austin. We had something set up in Seattle. So really just all over the place. So this is a talk that I developed firstly for the AWS meetup group in Denver, and turned out to be something I could reuse here and share and really kind of tailor to Code PaLOUsa. So anywho, let's get going. So in terms of what we will cover today, just a general overview of infrastructure as code, commonly denoted IaC within the industry. Then we'll take a look at Terraform, and look at a hello world sort of first deployment. Then we'll get into a stack that I have created within Terraform. I call it my IaaS hosting stack. It involves an EC2 instance, an RDS instance, and all the networking that goes with that. Then I'll go ahead and deploy that with Terraform. And then let's jump into Pulumi, which I think if you look at Terraform kind of as the incumbent, Pulumi is the upstart. And we'll get into that. I'll give you an overview of that. We'll go through the deployment, kind of look at the code there, and then just a few words on, you know, picking your tool. And I think this really comes down to, do you sit more so with the development side of the house or more so with the ops side of the house? Okay, so I do have a repo, and I've put the link to this slide deck in the chat of the presentation. So if you want to follow along, that repo is out there. And then also, if you want to get back into the session for Code PaLOUsa, I've got a link here for that as well. So a bit about coded infrastructure. So we have a declarative representation of a known good state of resources. Where do the resources live? Well, that's a great question. They could live in a cloud provider, such as AWS, Azure, on-prem, pretty much, depending on the technology used, it could be just about anywhere. One of these technologies is more applicable to an on-prem type of deployment. That'd be Terraform, and Pulumi is more of a cloud-first type of deployment. So there's your, you know, if you're coming to this talk to kind of figure out which tool is better for you, that's certainly something to take note of. If you have on-prem deployment requirements, that's going to be something that probably drives you more so towards Terraform. And so another benefit of the coded infra is it's repeatable. And so we have the high fidelity duplication of production environments that we can then take down to a testing environment, a QA environment. We can basically just redeploy the same known good infrastructure anywhere we want to with the change of configuration and not have to go and hit all the buttons and try to remember every single step we took. And so in the event of environmental issues, something has broken, well, you know, do you want to troubleshoot it? No, I want to actually just create another environment, get my application back up and running, and then I'll go ahead and behind the scenes go back and figure out what happened in the meantime. But first and foremost, get the application back up, get your users back into their services, and then figure out, you know, kind of what went wrong. And so this also allows you to integrate the stand-up of infrastructure into a CI/CD pipeline. And I've got a CloudFormation version of this talk if you want to go more so pure AWS native tooling, but let's go ahead and skip over that for now. And so let's talk about what I mentioned as the incumbent. Terraform, fantastic company. WWT, Worldwide Technology, where I work, we are partners with HashiCorp and Terraform. We are super big on the technology, released in 2014, and it is probably the most widely adopted infrastructure as code technology that I'm seeing. There's some other alternatives, but it's definitely winning the industry. And so this allows for the definition and provisioning of data center and cloud infrastructure. Again, going back to that data center aspect, the on-prem aspect of this, if you've got on-prem stuff, probably look towards Terraform over Pulumi. And so you can use the high-level configuration language called the HashiCorp configuration language, commonly denoted HCL, of course, or JSON if you want to. So that's a matter of preference. I think I see more people using HashiCorp, or the HCL from HashiCorp. So I think that's a more standard approach. So the goal here, building, changing, versioning infrastructure. Keyword here is safely. This lets you go ahead and evolve your infrastructure as your products and your applications evolve and have new infrastructure requirements. And so it can be used to provision on many, many platforms. And so this is done via what's called a provider. And so they have a provider for AWS, a provider for Azure, GCP, Baba Cloud. It really just goes on and on and on. I think they have a provider for GitHub. So if you want to go and stand up repos in a coded manner, you can do that with Hashi. And so to get into kind of what is Terraform, two flavors exist. Firstly, there's Terraform Cloud, which is what I think at the startup level, kind of the cloud first level, that's what we see people using. And then there's Terraform Enterprise, where you get to store state on-prem on your boxes, could be on EC2 instances, et cetera. And so that's pretty nice too. And sometimes there's some requirements to have that extra level of control. And so I did want to put that out there as an offering that they do have. And so for this lab, we're just going to use the Terraform CLI, which is going to store the state locally. And so we're not really going to get into either. That's not necessarily the focus of this, is really diving deep into Terraform. Focus of this is to look at the two technologies and what is the experience like. I think that's really the most important thing. And secondly, like, what are the applicable use cases? And so to just get through a couple base definitions, provider is responsible for understanding the API interactions and exposing resources. And so, you know, with AWS, you can be calling their APIs to stand up things there. Within Azure, they've got their own APIs that you can call. And this goes on and on and on with like Heroku as well, Datadog, et cetera. So basically, this is an encapsulation or an abstraction, really, around how to interact with a platform. And so with this, you can create repos, CI/CD pipelines, data center infrastructure, cloud infrastructure, serverless infrastructure. It really just goes on and on and on. And they do have an extensive list of the providers that they support. I recommend looking that up if you want to figure out, you know, is what I'm trying to make supported by one of these two technologies. And so let's go ahead and skip over here. And so to get into the Terraform approach, it's a three-phased approach. You write, and so that's writing of the Hashi configuration language with JSON that is the declarative state of your resources. You can plan, which would be what does it look like to, so we have some things deployed out to, let's just say AWS. So we have some things deployed to AWS, and then we make some modifications to our configuration files. We run a plan to see what's the delta and what would happen when we actually do apply the new version of the configuration files. And so finally, that leads to apply, of course, which is going to be the actual application and instantiation of resources. And so to get into the right phase, the creation of the configuration files is basically what you're doing there. For the plan phase, there's an execution plan, which it creates the execution plan, which defines what it's going to apply. During this, it builds what's called a resource graph. And so let's say that you have an EC2 instance and you have a VNet, right? EC2 instances need to live in a VNet, right? You can't really instantiate the EC2 instance until you have the VNet. So it will create a graph of all the resources and figure out what's dependent upon what. And this is very important. This allows you to write these big, massive, complex projects and then kind of let the technology figure out the ordering in which things need to be deployed. So very, very important. We won't get too deep into that. It gets pretty complex, but it's kind of magical. And then the change automation, creating of the change sets, applying them in order, and then basically just getting your resources out there. So to get started with Terraform, we're going to go ahead, and these are mat commands for the most part that I will be using. It's just if you use Homebrew, it's a simple brew install Terraform. So there's also a manual download. I tend to use a package manager. I would go with Homebrew or Chocolatey, depending on your operating system of choice. But it's really personal preference and what makes sense to you. All right, so in order to be able to pull off these steps as well, the creation of an AWS account or CLI account is also required. I think a lot of people have probably been through these steps, but once you get into IAM within AWS, you can go ahead and create a user, add them to a group, and then you'll get some credentials. You only get the chance to get this access key a single time, so don't let that screen pass you by without either downloading the CSV or manually copying and pasting, so on and so forth. So another aspect to this is to run this stuff locally, we need the AWS CLI. So again, it's the brew install AWS CLI. If you're a Mac and you want to use Homebrew, they've got a bundled installer. There's several ways to do this. If you're on Windows, go ahead and just run the MSI installer that is linked from the presentation. And then additionally, you'll have to configure your local environment to be able to connect over into AWS. So once you have that AWS CLI, it's just AWS configure, copy and paste your ID key or your key ID and your access key itself. Select your region. I go with US West 2 these days, but whatever suits your needs best there. It's probably worth noting that not all services are available within all regions of all of the cloud providers kind of work this way. So a good example of that is if you want to run EKS on the West Coast, you're going to want to use 2 and not 1. So make sure whatever it is that you are deploying is actually supported by the region if you are going against a cloud platform. Okay, so we'll start with a very simple kind of hello world sort of example of getting into Terraform, and I will go ahead and start to switch over into the command line. I realize this is very small. I do apologize. Let me go ahead and get out of the show so I can start doing the fun stuff. So, all right, so where are we? Let's see. Okay, let me zoom in here. I apologize. I'm sure that was not a great viewing experience. And so here, what we've got, this is the Hashi configuration language, is we're going to go ahead and create a VPC, call this main. And so the syntax here is this, we're going to specify a resource. it's going to be an AWS VPC, and then it's going to have a name of main, and then specify some parameters, for example, a CIDR block, whether or not you want to support DNS, if you want to support host names, and then also some tagging. A quick aside on tagging, tag all your resources, trust me. And so then we're going to go ahead and stand up an AWS subnet. We're going to call this the main subnet. And this is pretty neat. This is when you get into the resource graph. And so this AWS subnet relies on a VPC being available. And so with that being the case, you can reference the subnet here. And if any of you have used Hashi in the past, you'll probably say, well, why are you quoting your variables like this? I'll get into that later. It's not lost on me, but it is a thing that I'm doing then. Is maybe, I think it's about one version old in terms of syntax. And so going back into here, let's go ahead and just get up to the top of the terminal, take a peek at our files. So the first thing you want to do is init the backend. So it sees that we're using AWS. So it's going to go ahead and download the provider, the plugin for the provider there. And give this a sec. It says, cool, we're good to go. Zoom in just a touch more for the presentation. And so now that we've went ahead and done the init, let's go ahead and see what Terraform wants us, when Terraform applies this configuration, what is it going to do? We can ask that from Terraform when just by simply issuing a plan command. And so this comes through and it says subnet will be created. All this makes pretty good sense to me. You specify availability zone, IP CIDR blocks, et cetera, et cetera. And then also you've got the VPC that it lives in. And so I've got some warnings here because I'm quoting my variables. As I alluded to, pay no attention to the man behind the curtain. So here, if we want to, at this point, whoops. Terraform has now told us what it would do if we went ahead and applied the configuration. Well, why don't we just apply it? So I'm going to get over here into the portal, and we're going to look for the VPC service here. Let me zoom in on this. I am deploying this into, oh, sorry. And it will prompt you to deploy your resources as well. So let's go ahead and give it a yes. Let it do its thing. And over here in Northern Virginia, US East 1, we've got some VPCs. So this all gets deployed and sent out. So it's still doing its work. So it goes ahead and outputs the VPC ID here. So voila, we now have a VPC. And if we wanted to dig down into its subnets, we certainly could. For the sake of time, let's go ahead and just assume that that is all out there. Okay, so now we've specified the resources we want. We've instantiated them with the apply command. This is just a hello world, so let's go ahead and delete them. Always delete your resources unless it's a production project, obviously. But if you're just messing around, go ahead and make sure you delete your things so you don't get charged. In this case, it's a VPC and a subnet, so it'd be pretty darn cheap. That's not the case if you want to go ahead and deploy a Redshift instance or Azure Data Lake or whatever it is that you're working in. So this is as simple as Terraform destroy. And then it will prompt me. And there is a switch to not have it prompt you. Like most CLI commands, you can go ahead and override and just make it do the thing without asking you. I always like to ask, especially in these demos. Cool. So now we have gone through our hello world. Oh, hey, look, it's me. All right, back into the presentation. So as you can see, the Terraform init command was ran to get the provider in place. I'm probably not going to go back into full screen on the slide deck. bear with me as I get this into a little bit more presentable form. Okay, thank you. And so with that being the case, Terraform and init went ahead and downloaded the appropriate providers, etc. Then we did a plan, and it said, I'm going to create a VPC and a subnet. We said, perfect, that's what I asked you to do. Then we applied it, and went ahead and put it out there. And then the final command here is Terraform show. So I kind of glossed over that, but if you have some resources deployed, you can do a Terraform show, and it will show you the current state of the world based on your configuration file. So we've already seen this, so we'll just get through this pretty quickly. So Terraform and init, obviously, and then Terraform plan to see what the changes will be. The apply looks something like this. And then if we did a show, it would look something like this. And sorry about the small text there. It's just a screenshot. And then also, as I mentioned, tagging. You can get into your resource groups and browse for things with tags. I always tag my resources, so that way if I put in the project ID and the tag field, it'll go ahead and show me everything that I have deployed. And so with that being the case, we've already gone through the destroy. So we're in good shape here. We're in good shape. I'm going to do a quick check on the chat. Okay, no questions there. The inception occurring there. Okay, so let's get into something that's really, I think, a little bit more compelling, right? Like a VNet and a subnet's great, but what application is going to run on that? We need more. We just need a lot more. So this is a hosting stack that I've coded up in several different languages, IaC languages. And just to give you an overview of what we will deploy within AWS, we have a region, VPC. So we create the VPC. We go ahead and create a public subnet. This is very common. So within the public subnet, we've got an EC2 hosting instance. I refer to this as my IaaS hosting stack. So this is the host for the website, if you will. And then it has a security group that allows 22 and 80/80 inbound. So that allows us to SSH into it and then also route 80/80 HTTP traffic into it. Excuse me. And then secondly, we have a subnet group over here with the DB security group. This security group only allows 3306 from the instance security group. And so what we have here is a public EC2 instance and a private RDS instance. And this can do a multi-AZ redundant deployment. I've got a line commented out that would make it deploy into A and B. It takes about 15 minutes to deploy into two subnets. It takes about 5 to deploy into one. So for the purposes of the demo, I just stick with that. And then finally, route table association going out to an internet gateway, and then a VPC default route out to the internet gateway. So this way we can route traffic from the VPC to the internet. And if we didn't do that, we would not be able to communicate with these resources. Well, from the internet, we can only communicate with this one. So if we actually want to communicate directly with RDS, we have to hop into the EC2 and then hop into RDS. So that's probably a conversation for another talk, or at least a longer talk. So with all that being said, I've got some basic overviews of the components that are being stood up. So I think for the most part, these are all pretty straightforward. And then also the RDS instances as well. So with that being said, if you want to get more into this, the link to the slides is available in the chat. And so let's go ahead and dive into the various parts of the actual IaaS hosting stack. So let's see here. I went ahead and pulled all of this down ahead of time. Let's just pull it up in Visual Studio Code. Whoops. Let me make this a little bit wider. And at this point, let me get into the Terraform. So kind of starting here, we've got our VPC. This should look familiar. We specify our subnet, specify the subnet for the database failover and the main, as well as the internet gateway, the route table association, and also the VPC's default route table. So this is just using that Hashi configuration language. I think an important note here is there's not really an ability to drill into these resources and see. So if I wanted to figure out what all the different arguments here, there may be editor support for this, maybe a separate plugin, but it's a little bit more difficult than using, like, say, a natural programming language where you can just go to source and view that sort of, and kind of view the actual code as documentation. It's pretty neat. That's more so something I get out of Pulumi. We'll get into that in a second. So additionally, we have our DB subnet group, the security group around the database, the database instance itself. And here is where I was saying I have the multi-AZ commented out. It definitely adds time to the deployment there. And so there's also the EC2 instance itself. And so let's go ahead and jump forward since we're running a little short on time. With that being the case, let's see. So with all of those Terraform files, you can see, actually, let's go ahead and you can see all of these Terraform files here. So these are it's going to look at all of the TF files minus the TF state and TF backup. It's going to look at star.tf files and go ahead and deploy those out. So we'll do a quick Terraform plan. And looking at all of those .tf files, Terraform will come back and tell you what it is that it would deploy. So while it's doing that, let's jump back over to the slides. And let's see here. So we're basically down into here where we're going to go ahead and do another init plan apply. We've already seen that, so we won't get too far into it. But on the plan, it goes ahead, it's got the VPC, it's got the subnet, it's got all of the things. So we won't get into every single one of those. We kind of already saw that from the actual Hashi configuration language files, the .tf files, if you will. So we're in a good spot there. So if you want to dig further into that, definitely check out the repo. It's actually the combination of two projects from AWS Labs. So I don't know that this exists in an out-of-the-box version. So this could be something that could be useful for one of your customers, your company, et cetera. This is a very common hosting stack. So this is a bit of a freebie that I've created for the community. So if you want to get further into it, if you think this IaC hosting stack is something you could use, feel free to grab it and run with it. The bones of it come from the best practices out of AWS Labs. So it's pretty good. It's a pretty good starting place for a basic hosting setup. So let's go ahead and jump into Pulumi at this point. And this is from the Pulumi website, open source platform for building and deploying cloud infrastructure in your favorite language. And I think this part is super huge right there, favorite language. So as someone with a software development background, I don't like to have more languages than I need to. And so let's say I'm writing a project in C#. Do I really want to have coded infrastructure in a different language? It would be super cool if I could just do that in the same language, have it in the same project. Of course, you can have like the HCL files, the .tf files in your same project as well. But I think it's just context switching is a bit of a killer in terms of productivity. So you don't have to context switch between two different languages, if that makes sense. Bear with me here. And so with this being the case, worth pointing out that the supported languages from Pulumi, JavaScript, TypeScript, Python, .NET Core, and Go. I have used it predominantly in TypeScript and .NET Core within C#. Very awesome to be able to use the same language for your infrastructure as you do for your actual application code. I find that incredibly valuable. So in order to use Pulumi, you'll want to go ahead and create an account out there and create an access token. As we have 15 minutes to go, I'm not going to go through this step by step, but I will get into some of the instructions to get Pulumi going on your local. This probably is a theme that you're noticing with me. Brew install Pulumi. Just use the package manager. Chaco install Pulumi on a Windows box. If you want to do it the hard way, I've got that there. Would not recommend it. And then there's also an AWS plugin for Pulumi that I use. So getting into Pulumi and kind of what we've got here. Let's go ahead and take a look at the files. Let's take a look at the code. And so here, I just have a large index.ps. And so it's an import from Pulumi. If you're familiar with TypeScript or even JavaScript, this will look very familiar. Then you go ahead and pull in your provider, in this case, AWS. And then I go ahead and set up some constants. And this goes into me with a development background. You know, I kind of prefer this a little bit more. Again, Hashi, Terraform, it's a great tool. We use it all the time. I use it in production projects, probably more than Pulumi. But just for me, like for how my brain works, I think this is, for me, it makes more sense to have, you know, constants and stuff of that nature. You can do these constructs within Hashi as well. But this is a syntax that I recognize and know by heart, if you will. So set up some variables. You can get it off of the environment. And then you can, if it's not there, you can go ahead and no coalesce into your default value. So, you know, you're already seeing some stuff that's maybe a little bit more developer-centric, no coalescence or coalescer, etc. These things are very good, I think, for developers that are starting to venture into coded infrastructure. And so very similar stuff here, but you start to get a little bit better intelligence around the offerings. And again, I bet that there's some plugins for your IDEs to do this with Hashi. Given it's TypeScript, it just kind of works out of the box with most editors, and you don't have to go and install plugins. So again, VPC, create a subnet. I've got a main DB subnet, failover subnet, route table. All of these things are, you know, very similar. I think this is interesting. I had to get the AMI here. The AMI is the Amazon machine image. And so I go out and get the most recent image. And this is important when we get into the EC2 instance, where we go ahead and specify the Amazon machine image. So that can also be done in HashiCorp. This is Pulumi's representation of it. So this continues on. Very similar, it just creates, you know, all of the same stuff. Again, the commented out multi-AZ. Excuse me for a sec, I'm gonna jump to the chat. No, looks like, make sure I'm at the bottom. Okay, cool. Looks like we are good to go on questions from the chat. To me, you know, this is a little bit more intuitive. It's a language that I understand, but it's almost one-to-one. And in fact, the Pulumi uses the Terraform bridge. So if something's not supported in Terraform, Pulumi is not able to use it. So it's probably worth noting there. All that being said, let's jump back into the slide deck. And so once you've gone ahead and set up your credentials, let's see here. So from the repo, okay. So you can just set up if you're going from scratch and all you have is that TypeScript file, set up a new Pulumi project. It will ask you, what is your language? You're going AWS TypeScript. I'm just going to go with my defaults here. It's pulling that off of the directory name. And we'll go ahead and do this. I am, as I mentioned, US West 2-man these days. So it's going to go ahead and do all the the setup things, pull your dependencies, pull the provider, etc. Very cool. So at this point, we can go ahead and pull in the index.ts file to the local. So if we do a ls, which I've aliased as L, I think that's a Z shell thing, actually. Excuse me. We'll see we have this index.ts file. So let's just make sure we have the right index.ts file. Okay, so just a quick sanity check says there's a ton of stuff in this file. It's not empty. So that's cool. So typically do an npm install here. That will go and get you any providers that you don't have. I've got some warnings, no license, etc., but we're in pretty good shape here. So at this point, if we wanted to, so if you remember your Terraform commands, you've got Pulumi you've got Terraform and init, and that's similar to, since this is a TypeScript project, the npm install. So the next thing is, well, what's the equivalent of Terraform plan? Well, we don't really necessarily have that. With Pulumi, you can issue a Pulumi up command, and it starts to look through the TypeScript files, and you can split that index.ts file up into multiple files and just do imports, similar to what you do with Node inside of a TypeScript or a JavaScript project. So this is going to come out here, and it's going to say, hey, this is all of the stuff that I would like to make. And you say, well, no, actually, I do want to make it. Okay, so it gives you the prompt. You can certainly tell it no, or you can tell it to us. This is the preview. In Pulumi, that's the kind of the phrasing is, this is your preview. You can say you can see it's got previewing update there. That's all pretty cool. So you can do a -- skip preview, and that's what you would do if you're deploying this from like Jenkins or code build, CI/CD, pipeline of your choice. You certainly don't want that prompting in your automation. So that's certainly something that you can do. So this is going to take a few minutes. So let's jump back into the slides. So we've got about 8 minutes, 7 minutes to go. And so here we go, Pulumi up. That is our command to get into that. The deployment, it goes ahead and starts that. Since we did not skip the preview, we manually specified that we want to perform the update. And then we also have a Pulumi destroy command. So let's go back over to the console. And you're going to see that the RDS instance, that's the thing that takes a long time. So while that's coming up, let's go ahead and talk about why I had quotes around the variables. All right. So let's say you have some Terraform. You're like, well, we've decided to shift. We're going to go to Pulumi for whatever reason. There is a TF2 Pulumi utility that will convert from Terraform into Pulumi. And so we can take a quick look at the repo here just to get a better understanding of it. So let's get out of the releases. I'm not sure why I linked that. Anywho, so this is a Pulumi supported repo. So it is, it's got support if it's something that, I always check to see if there's support for a project before I start, using it for production purposes. Make sure it's not something that's going to be kind of orphaned and unsupported. So with that being the case, you do need to have Go installed. And so if you want to get into this conversion, this TF2 Pulumi utility, it's great, but there is a little bit of setup here. And when I did the conversion from my Terraform for the last time I did this talk, I had to have those quoted identifiers or else this blew up. So my Terraform had to be 0.11.x compliant. So going back to why in the world do we have these silly quotes around the variables, for example, right here. That is why, otherwise I would not have the this kind of string interpolation going. I think it looks a little sloppy, but I don't know, 0.11 compliance. let's go ahead and check our console. Okay, like I said, that RDS instance, it's a beefy one. It takes a while. And also, if you're following along at home, if you get this repo and decide to play with it later, the RDS instance is the expensive part of this thing. So always destroy your resources. All right. So getting a little further into the conversion here, create a new project. And we're going to do it in the directory IaC hosting stack. And in our description, I took the defaults for the most part. And also, if you want to use various versions of Terraform, just as a quick hint or tip, there's a utility called TFINN, which you can go and specify which Terraform environment you want to use. In this case, like 0.11.14 would be 0.11.x compliant. So I brought this here so I could like test out my Terraform to make sure it was compliant with 0.11 before going ahead and converting it. And so at this point, the command is just tf to Pulumi, then output that to a file. This was our directory, so you could even put a / there and then index ts. And so that's I think that's pretty neat. It was one of the things I really enjoyed when I was starting to research this for this talk. When I first did it initially, last year. And so at that point, after you do the conversion, npm install, you can specify the provider, or you can just do an npm install. And then there's a little bit of an update if you're following along at home. Given where we are at time, I'll let you dig into that on your own. You can go ahead and configure the region, do a Pulumi up, and that will get you into this page here. And you can see that we have actually gone ahead and created all of our things. Quick sanity check on the resources. We are in Oregon. Okay, so we've got this default database with what looks to be a generated identifier at the end. That is me. These IaC tools will tend to generate identifiers so that you don't have naming conflicts. It's just a kind of a best practice, or I don't know if it's best practice. It certainly keeps you from kind of trampling your resources when you don't expect to. And so let's see here. I think yeah, so we've got our stack out here. So now that we've successfully deployed, we've created a stack. And one of the cool things around the Pulumi cloud is you can get out here and see your stacks. See, we're running pretty short on time. So you can actually go out to their portal and see all of your resources with direct linking into them. So pretty neat stuff. All right, so the payoff. And I think this is the point of the whole talk is, like we've got these two really great tools. We've done great work with both of them. How do I pick what I want to use? Okay, so firstly, I find that a dividing line of demarcation, if you will, is do you come from a development background or more of an admin ops background? I tend to see people from the admin ops background, maybe they've worked with Ansible, for example, they tend to gravitate towards Terraform. Developers, they tend to like to write the application and the infrastructure in the same language. So I think that kind of tends to get you into into Pulumi. And then also you've got to go to source. Let me show you that very quickly. We get into index.ts. If you wanted to figure out what all arguments go into the VPC, you can actually get into the source code and check out the arguments itself. So this is cool for developers because you have self-documenting code. And so you don't have to go out and look up the the tech specs from the web. It's just right there in your editor. So definitely C developers tend to deploy or prefer Pulumi. Do you have on-prem components? Pulumi's cloud first, so you're going to need to get Terraform there. Also, do you need to keep your state in a non-cloud-based place? Then you'd probably go into something like Terraform Enterprise. So that's certainly another decision point there. Go. So those are kind of the big decision points around Terraform and Pulumi. Like I said, both are great tools. So what we've covered, intro to Terraform, getting started, hello world, also a complex multi-file stack, intro to Pulumi, deploying the same complex stack with Pulumi, and also that conversion, that TF to Pulumi. So I'd like to thank you all for joining. I'd also like to thank Code PaLOusa for organizing. It's amazing that this still came together in, I guess, in the lens of coronavirus and COVID-19. Quite the pivot, to say the least. And then hit me up on LinkedIn or in the chat if you have any questions. And one final view of, oh, yeah, absolutely. I was happy to share, guys. It looks like we have no questions here. So I'm going to go ahead and sign off as we are a little past time. Thanks, everyone, for joining. Again, hit me up on LinkedIn. Very easy to find, Kevin TINN. Happy to answer any questions you may have. Hope you all have had a good week at Code PaLOusa, and the rest of your day is good as well. All right, thank you so much.